third rule, that is Hund's rule. So what this Hund's rule says? According to Hund's rule, each electron will enter into each degenerated orbital first. After filling up of all degenerated orbitals with each electron, then the pairing starts. So let us first understand what is degenerated orbital. Degenerated orbital means the orbitals having same energy. So these are called degenerated orbitals. So let us try to understand this Hund's rule with an example. So now first we take carbon atom. See, the atomic number of carbon atom is 6. That means carbon atom has 6 electrons. So this is the first shell. That means in the Aufbau principle we have discussed that electron will enter into orbital having lowest energy. So 1s orbital has lowest energy. That's why the electron first enters into 1s orbital. So 2 electrons fill in 1s orbital, and as per Pauli's exclusion principle, there is place for 2 electrons in each orbital. That's why in 1s orbital 2 electrons have been occupied, and then it will move to the 2s orbital. So carbon has totally 6 electrons. Among these 6, 2 electrons have already filled here, and in 2s orbital here also 2 more electrons will fill. So now totally here 4 electrons have been filled. So among 6 electrons, 4 have already filled. That means 2 more electrons remain, where these 2 electrons will occupy. So in 2p orbital we have 3 degenerated orbitals. That means px, py and pz. And where these 2 electrons will enter? First, according to Hund's rule, each electron has to occupy each degenerate orbital first. So 5th electron will enter into 2px orbital, and 6th electron will enter into 2py orbital. Same like that, if we take nitrogen atom, its atomic number is 7, and that means nitrogen has 7 electrons. So 2 electrons in 1s and 2 electrons in 2s. So among 7 electrons, 4 electrons have been filled. That means 3 more electrons remain. And where these 3 electrons will enter? The 1 electron will enter into px, and the 6th electron will enter into py. 7th electron will enter into pz orbital. So here all the degenerated orbitals have been filled with each electron. And now take the example of oxygen atom. Its atomic number is 8. That means oxygen atom has 8 electrons. And among these 8 electrons, 1s will be occupied with 2 electrons, and 2s will be occupied with 2 electrons again. So among 8 electrons, 4 electrons have been filled here. That means 4 more electrons remain. And where these 4 more electrons will be occupied? 1 electron will be in px, 1 electron in py, 1 electron in pz. Now we have 7 electrons. That means in these 2p orbital, each degenerated orbital has been filled with each electron. And where the 8th electron will be? As oxygen has 8 electrons, 7 electrons have been filled already here. The 8th electron will be starts pairing. That means it will enter into px. So same like that, if you take fluorine atom, there will be 9th electron also. The 9th electron will enter into py. If you take neon atom, it has 10 electrons. The 10th electron will get paired in the pz orbital. Like that, while entering into orbitals, the electron has to fill. That means each electron has to fill in each degenerated orbital first. After filling up of all orbitals with each electron, then it starts pairing. So this is explained by Hund's rule. And these three rules, that means Pauli's exclusion principle and Aufbau principle and Hund's rule. These three rules we need to remember while writing the electronic configuration of an atom. So in the next class, we discuss about the electronic configuration, the procedure to write the electronic configuration.